Let's now discuss a little about second order operators. An example of a useful second order differential operator is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is called the Laplacian operator. We come across this operator in many fields of science and technology. In fact, we know that del square phi is equal to 0 is called the Laplace equation, and del square phi is equal to rho is known as the Poisson equation. Laplace equation and Poisson equations are well-known equations. Naturally, a question arises: do we come across such second-order operators in the context of vector calculus? Yes, we come across. Can we know where? If you consider divergence of gradient of f. In fact, divergence of gradient of a scalar function f is equal to del square f. What is del square here? It is the Laplacian operator. In this context, we can think of del operating twice on point functions. So in what we are going to discuss further, we are going to see divergence of gradient, curl of gradient, and then gradient of divergence of a function, curl of a vector function, and then divergence of curl of a function. Such functions, such operations we are going to discuss.